Next, we're going to talk about empirical formula from combustion analysis, or as your note says, empirical formula from chemical analysis. This is number 11 and 12 in your notes. So empirical formula from combustion analysis talks about when we analyze the products of combustion, can we figure out what the empirical formula was originally? Number 11 says, a 5.0 gram sample of a hydrocarbon was burned in oxygen and produced 14.67 grams of carbon dioxide and 9.0 grams of water. Find the empirical formula. So the empirical formula is the mole-to-mole ratio of carbons to hydrogens. So I'm going to write a chemical equation, but I can't write a balanced chemical equation because I don't actually know if that's C6H6 or C2H5 or C1H32. I have no idea. But a chemical equation is always a good place to start. It's a good place to visualize the reaction. So if we started with 5.00 grams of this carbon-hydrogen compound, and it was burned in air, so I have no idea how much oxygen came from the air, I end up with 14.67 grams of CO2 produced and 9.00 grams of water produced. So from that information, I have to figure out how many moles of carbon we started with and how many moles of hydrogen we started with. So for the carbon, notice that there's carbon in the beginning of the reaction, and notice that there's carbon in the CO2, and that is the only two places that carbon appears at all in the reaction. So if we can figure out how much carbon is in this 14.67 grams of CO2, then that's got to be the same amount of carbon that's in the 5.00 grams of the unknown compound. So CO2 is 12.0 for carbon plus 2 times 16.0 for each oxygen. It's a total of 44.0. So in a mole of CO2, carbon is 12 out of the 44. What about in 14.67 grams of CO2? How much is carbon? Set up a direct proportion, cross multiply, and solve for x, and x ends up being 4.0 grams of carbon. We can do the exact same thing for hydrogen. Notice that hydrogen only appears in the equation 2 times. The hydrogen from the original compound turned into hydrogen from water, and that's the only place that hydrogen came from. So if I can figure out how much H is in the 9 grams of water, then I will know how much H is in this unknown CH compound. So for water, that's 2 times the 1.0 for each hydrogen, plus 16.0 for the oxygen is a total of 18.0. And hydrogen then is 2 out of the 18. How much hydrogen is in the 9? Solve for x, and x is equal to 1.0 grams. That means out of this original 9 grams, only 1 gram is hydrogen, and that 1 gram had to have come from the original compound. Out of this total 14.67 grams of CO2, 4.0 grams is from the original compound, because 4.0 grams is the carbon. Now that we have the gram-to-gram ratio, 4 grams of carbon plus 1 gram of hydrogen ends up equaling this total 5.0 grams. Now we can find the mole-to-mole ratio so we can get the empirical formula. So for the mole-to-mole ratio, carbon weighs 12.0 grams for 1 mole. And this gives me 0.33 moles. For hydrogen, hydrogen weighs 1 gram for every 1 mole, which gives me 1 mole. Then we run a divide by small, which will give me the benefit of making the smallest number 1 and the larger number, hopefully a whole number larger than 1, which in this case is 3, which tells me that my empirical formula, my mole-to-mole ratio, is 1 carbon for every 3 hydrogens, or CH3. Number 12. A 1.55 gram of a CHO compound are combusted for analysis, which yields 1.45 grams of CO2 and 0.89 grams of water. Find the empirical formula, which means find the mole-to-mole-to-mole ratio of carbon, hydrogen, and oxygen in the original formula. Okay, so first thing I need is a balanced equation. I've got some CHO compound. combusted means added to oxygen to produce CO2 and H2O. There's a barrier to balancing this equation because I don't know how many carbons, hydrogens, and oxygens there are. That's what I'm trying to find. But at least I can use that equation to set up my knowns and my unknowns. 1.55 grams of the CHO, 1.45 grams of the CO2, and 0.89 grams of the water. So let's start with the carbon. There is carbon in CO2, and there is carbon in CHO. And it happens that those are the only two places that carbon appears in this equation. So all of the carbon in this 1.45 grams of CO2 had to have come from the carbon in this 1.55 grams of CHO. So for carbon, it weighs 12.0 out of a total of 44 for CO2 from the periodic table. So 12.0 grams out of 44.0 grams, the molar mass off the periodic table. How much of that carbon is in a 1.45 gram sample? So solving for x, we get x is equal to 0.395 grams of carbon. So for hydrogen, all of the hydrogen in this H2O, all of that hydrogen from the 0.89 grams, has come from the 1.55 grams of the CHO compound, because hydrogen only appears in those two places in the equation, and that's it. So with water, hydrogen weighs a total of 2.0 out of 18, because there's two hydrogens in water, and they weigh 1 each. So how much hydrogen is in 9.0 grams? Cross multiply and divide, we get x is equal to 0.0989 grams. Yeah, let me see if I can... I said 9 grams from the previous problem, but it should have been 0.89 grams. So I get 0.0989 grams of hydrogen. So now for the oxygen, that's the trick. Because there's oxygen in CO2, and there's oxygen in H2O, and there's oxygen in the CHO compound, and there's oxygen in the O2, and there's oxygen everywhere. So how much oxygen came from the CO2, and how much oxygen came from the H2O, but even after you know that, what of that came from the original CHO compound, and what came from O2? Well, you know that this CHO compound weighs a total of 1.55 grams, and 0.395 of it is carbon, and 0.0989 grams of it is hydrogen. So whatever's left has got to be oxygen. So taking that 1.55 grams total, subtracting out all the carbon, which is 0.395, subtracting out all the hydrogen, which is 0.0989 grams, whatever's left has to be oxygen. And in this case, that is 1.056 grams. Now that you have the gram to gram to gram ratio, now you should be able to find the mole to mole to mole ratio to find the empirical formula. So 0.0395 grams of carbon. Carbon weighs 12.0 grams for every 1 mole, and that gives me 0.329 grams. Sorry, make that moles. For hydrogen, that is 1 gram per mole. So that's 0.0989 moles. And for oxygen, it's 16.0 grams for every 1 mole, which is a total of 0.066 moles. And I think I've got a decimal point missing here. You might want to check me. 0.0329. Okay, so my next step is divide by the smallest. Remember that divide by the smallest gives me the bonus of making the smallest one 1. And everything else, hopefully, a whole number greater than 1. In this case, I get 3. And this time I get 2. all of these are whole numbers, so I have C1H3O2 or CH3O2 as my final answer, as an empirical formula.